Hi friends, it's Laura Marie. This is a second video for Grade 4, Unit 4, Illustrative Mathematics End of Unit Assessment. We talked through all the answers and the content on the assessment in my earlier video. This video is really talking about number 8, the last question. They start by comparing the number of students in Los Angeles and New York City in 2016. They find the difference. And then they're asked to find how many more students does New York need to have in order to have 1 million students. Explain or show your reasoning. When I looked into this, I noticed that the solution paths suggested in the answer key don't really play a predominant role in any of the lessons in Grade 4, Unit 4, Illustrative Mathematics. So I'm going to talk to you a little bit about the two strategies that are suggested in the answer key, and also give you a link to a video where I rewrote Activity 1 in Lesson 22 of Grade 4, Unit 4 to give students an opportunity to practice or talk about at least these two strategies. So I'm going to switch over to my document camera. Okay, so in the last problem, we are thinking about the New York City School District, and they have 984,462 students, and they need to get to, or how many students would it take for them to have 1 million students? So we're trying to find the difference, which traditionally most kids are going to set up by writing out 1 million minus 984,462. Unfortunately, if students only know the algorithm for subtraction, this leaves them in a position where they will need to regroup across all of these zeros, which leaves lots of opportunities for mistakes. And students often encounter problems like this, and they really struggle to keep track of all of that regrouping. So we're going to look at 2 or 3 other possibilities. I'm trying to find the distance between the 2 points. If I move both points just one to the left, that will give me one less than each of those, which is 999,999 and 984,461. So this subtraction would be substantially easier because there is no regrouping that I have to do in order to find this difference. And because I changed both numbers the same amount, so I took the original problem and only took away 1 from each number, that makes it so that the difference or the distance between the 2 points on the number line stays exactly the same. One way to think about this is with children. My 2 kids are 2 years apart. They're 18 and 16. 2 years ago, they were also 2 years apart, and they were 16 and 14. And 10 years ago, they were 6 and 8, which is also 2 years apart. And next year, they'll still be 2 years apart. Because every time one of them gets older, the other one gets older. So when we change 2 points on the number line or 2 numbers by the same amount, the difference or distance between them stays the same. That's one way to solve this. Okay, let's think of another strategy to solve this, and this one is called compensation. So I am going to take away 1 from 1 million, which will get me to 999,999. And then I'm going to subtract to get the difference. So I will say 999,999 minus 984,462. And I'm going to do my subtraction. And I get 15,537. But I didn't include this one that I already took away before I subtracted. So I need to add that one back in because I subtracted 1 and then subtracted 15,537. So the difference is really the whole thing. So my actual answer is 15,538. So this one's called compensation because I take one away, then I subtract, and then I have to compensate for the change that I made before I did the subtraction. Let's look at another strategy to approach this. And this is where we think of this as a missing addend problem. So we know that we are trying to figure out what number do we add to 984,462 to get to 1 million. So when we write this down, we're thinking 984,462 plus what number gets me to 1 million. So doing all the regrouping to make all those tens is a pretty complicated missing addend problem. But again, if I think about what if I'm not trying to get to 1 million and what if I'm trying to get to 999,999? So now my problem is 984,462 plus what number gets me to 999,999. So when I do that, I can think 2 plus what number gives me 9, 7 ones, 6 tens plus how many tens gives me 9 tens, that would be 3 tens, 4 hundreds plus how many hundreds gives me 9 hundreds, that would be 5 hundreds, 4 thousands plus what number gives me 9 thousands, that would be 5 thousands, and 8 thousands plus, or 8 10,000s plus what number gives me 9 10,000s, and that would be 1 10,000. So to get from 984,462 to 999,999, I have to add to get from here to here is 15,537, but that only got me to 999,999, so I still need to go one more. And when I put those together, I end up with 15,538. Okay, now that we went over the strategies that are on the answer key for the last part of number 8 on the unit assessment, scan the QR code below to get to a rewritten version of Lesson 22, Activity 1. I changed the numbers and the questions a little bit in this activity to provide students with an opportunity to practice using these strategies when they're subtracting from a number that is one digit in the largest place value and the rest of the digits are 0. So it'll give them an opportunity to think about, talk about, or maybe try either compensation, constant difference, or missing addend with subtracting 1 to make an easier problem.